Hi, and welcome to part 3 of our linear programming question on green pepper, a transport industry linear programming question. Part 1 covered how to do the LP setup for the question, so deciding on your objective, decision, the function for your objective, and setting up your constraints. Part 2 focused on the solver setup for this question, so working out a structure for what you need to put into solver to get your optimal solution. Just to recap on what the question is about, we have Green Peppers, a company that needs to send its goods to 4 customers who have called Mary, Amma, Mrs. Bucket, and Jude. And each customer has placed a specific order. So Mary has ordered 35,000, Amma that much, etc. And these orders need to be delivered from 2 separate warehouses, and the amounts of product available at the warehouses are given on the right-hand side. So if our solution ultimately decides that it's only going to deliver from warehouse 1, then it cannot exceed that amount. The same applies for warehouse 2. Also, if we deliver from both warehouses, we need to make sure that we send exactly what the customer ordered. So if we send Mary a certain amount from warehouse 1 and warehouse 2, we need to make sure that those amounts add up to 35,000 units, which is what she ordered. We don't want to give her less because she wouldn't be happy. We don't want to give her more because we wouldn't be happy as the suppliers. What's stipulated in the question is the cost of delivery. So it costs $1 to get from warehouse 1 to Mary. It costs $3 to get from warehouse 1 to Amma. Jude is the furthest. It costs the most to get to him from warehouse 1. From warehouse 2, Amma is the furthest from warehouse 2. It costs $5 to get from warehouse 2 to Amma. And so because there's a variation in the costs associated with getting to each customer, we need to figure out what the optimal solution is that minimizes the cost of our delivery to these 4 customers coming from the 2 warehouses that we have. Okay, so having set up our solution, this video is a demonstration on how to use Solver to answer the question. So we're using OpenSolver. I'm just going to make things a little bit smaller so you can see everything. All right, so as mentioned in the previous video, when you set up Solver, I like to put highlighting on the cells that I need to give Solver. So I know I need to give Solver the constraints, and those are in pink on this side. And then Solver should give me back what's inside my table. It should tell me how many items to send to Mary from warehouse 1, how many items to send to Amma from warehouse 1, etc. for each cell. When it's done that, I'll be able to check if I've used up my capacity in terms of what I have available. So in here, I've already set up how much I've got in terms of whenever these answers get filled out, the sum of these should hopefully come up to less than 60,000, which is what's available warehouse 1. I've done the same for the customers. I cannot exceed the orders they sent or go under them, so the sign there is an equal to sign. So setting up your solver, the first thing you need to put in is your objective cell, and our objective is to minimize the cost. So that's what I have in green here. Our objective function has been restated here. So to minimize the cost, it's the number of items going to that customer times the cost of delivering to that customer from that warehouse. And we've done that for each of these cells. And the formula behind that objective cell is a sum product of whatever solver will give me times the relevant. The objective is going to be in cell E48. So I click in E48. Sorry, my machine is a bit. Click in E48 and then update the objective cell. Okay, I aim to minimize, so that's selected. If I wanted to maximize, I would select this. If I wanted to do a certain cost or a certain profit, I would just put the specific value that I'm trying to achieve. Normally that's with revenue, but in this case, we are trying to minimize cost. The variable cells are the cells relating to how much is going to be delivered to each customer. So I'm going to select all of those and click add. 42 to H40, which is correct. And then in OpenSolver, we have a tick box for the non-negative constraint. Unlike in Solver, where you have to stipulate the non-negativity as an extra constraint, here. So if you tick this box, you don't actually have to add in the non-negative. The extra thing you would need to add in is the integer constraint. And while we're there, let's start the constraints. Heading constraints, unlike in Solver where we have to add them in, OpenSolver allows you to select many at a time as long as they're using the sign. So do the warehouse constraints all at once, they're using the same sign, and then I'll do the order constraints at the same time. So, right, update that. I-42 and I-43, I want those to be less than or equal to my right-hand side. Update that. And save. Okay. That array being perfect. Next constraint is inside of the orders that they make. So whatever out of the warehouses must be equal whatever they ordered. So the right hand side. But my left hand side from E44 to H44, my right hand side from E46 to H46, which is exactly perfect. And the only are non-negativity, which are here. And I also want all of these outputs to be integers. I don't want to deliver half a bag of peppers. I don't pack like that. So I'm going to add a constraint where all of my decision variables from A42 to H43, everything that's within my table needs to be an integer. So I just select integer here, and that's all I need to do. Okay, and let's just review what we've done. My output is going into E48, which is my minimized cost. I want to minimize cost, so that's selected. The decision variables are E42 to H43. I want non-negativity. I have warehouse product availability constraints. So 60,000 available, 80,000 available, and I can't go over that. So here's my left-hand side, I-42 to I-43. The sum of what gets put into here by Solver must come up to less than the capacity. The same for customers. For my customers, I've got E44 to E to H44. Now I need to make sure customers that I'm giving them exactly what they ordered. So this time I change that to an equal to sign. E46 to E6, which is the array of the specific orders they requested. And then whatever the decision variables are, I've put the integer constraint. I'm happy with the solver methods to match whatever you would be doing, but this is appropriate for this question. I don't want to show the progress while solving. It'll just eat up my bandwidth. Looks like it shows the progress anyway. Okay, and it's found me a solution. My minimum cost has come up to, let's just change that. My minimum cost has come up to $200,000. And that is achieved by sending Mary and Emma's orders must come from warehouse 1. Jude's order will come from warehouse 2. Mrs. Bucket will get a combination of both warehouses. And you can actually look at the cost to see if this aligns with what you expected. So Mrs. Bucket is actually, relative to the rest of the group, she's closest to warehouse 2. So even though it would have been cheaper from warehouse 1, it still makes sense that she got something out of warehouse 2. And if we look at everybody else who's only getting from one warehouse, it looks like for Mary and Amma, warehouse 1 was the cheapest, so that's where they got their product from. For Jude, warehouse 2 was the cheapest, that's where he got his product from. Okay, and I'm just doing this to try and understand the solution. You do when you get your solution to any LP problem, just work through what you've been given to see if it makes sense, and also to understand how realistic it is. Anticipate whatever your client might say back about this solution. I'm happy with what's inside the table. I can understand those numbers. I'm going to now double check if I've used up my capacities. So for warehouse, I've used up everything available. Warehouse 2, I still have quite a bit of product available, so you can suggest to your client that with the rest of the product available, they can send that to other clients. Any other orders that follow would have to come from warehouse 2. And I'm happy to see that Solver made sure that everybody coded. Okay, so Amma, Mary, Mrs. Bucket, Jude, all of these numbers are equal. And that's your solution. You would do a conclusion and interpretation section where in the conclusion you explain that your minimized cost is $200,000 and these are the amounts that you would be sending to each customer. And then you do an interpretation in terms of trying to bring that back to you. Would your customer be happy with this result? What extra capacity does he have, if any, and make recommendations for what he could do with that extra capacity. I won't do that here. I think you should be able to do that yourself. And that's how you use Solver, folks.